Welcome back to the GCSE Maths Pro YouTube channel. This video today is going to be everything about factorising. So that includes everything starting from what factorising is in the first place and how we are going to factorise into single brackets. And then the bulk of the video is going to be focusing on factorising quadratics. Okay, so factorising into two brackets or into double brackets. We've got the trial and error method, which we're using for just straightforward quadratics where you've just got x squared. Okay, so it's not something in front of the x squared. Then the trial and error method for what we call harder quadratics, which is where we do have a number in front of the x squared. Then we've got the other option for the harder quadratics, which is to use the splitting the middle term if you prefer that method instead. And finally, factorising the difference of two squares, which is always a question every year in every exam, and it's just such easy marks to pick up on if you know what we're referring to by difference of two squares. Before we start, I just really want to emphasise, especially if you're doing higher tier, factorising quadratics is one of the most important skills to have and to be super confident with. Okay, you need to have it solid because it comes up not only in just a question where it says factorise this and it gives you a quadratic, right? It's not just that. It can come up in quadratic inequalities. It can come up in solving quadratic simultaneous equations. It can come up in solving or simplifying and solving algebraic fractions. It can come up in even questions to do with shape. A lot of the time they combine like the area of a rectangle or something, or even a cuboid, with algebra and you end up with quadratics. Okay, so it comes up in so many different topics throughout the syllabus. So you need to make sure you're really, really happy with it so that you can do it super quickly and accurately. So let's jump right in. We're going to start off with the basics of factorising into single brackets. So let's start with this first question. Factorise 2x plus 4. So first of all, what do we mean by factorising? Well, effectively, a word that we're looking at is factor. A factor is something that will divide into another number or another term. Okay? So we're going to be using the concept of the highest common factor for factorising. When we're factorising into single brackets, what we want to do is look at both terms here and see what is the highest common factor between them. So what is the highest common factor between 2x and 4? Now, this could be a number, it could be a letter, or it could be a combination of both. In this case, you can see that we don't have any letters in common. Only one of them has x. So we can't use a letter as a common factor, but 2 and 4, the highest common factor would be 2, as in we can divide 2 into 2 and we can divide 2 into 4, and that's the biggest number. So our highest common factor is what we're going to effectively pull out and put on the outside. So in this case, we've got 2 on the outside, then just put some brackets. The brackets effectively mean multiply. And then on the inside of the brackets, we're going to say, right, okay, well, we've pulled out 2. If I'm starting at 2 and I have to multiply it by something, how do I get back to 2x? Well, this one's pretty straightforward because 2x is just 2 multiplied by x, isn't it? So if I've already got the 2, the only thing that's missing is the x. So I'm going to put the x here, and then this 4 is a separate term. So the 2 on the outside you can see is positive, the 4 is positive. So we're going to put a plus because multiplying a positive by a positive will give us a positive. And then I go, right, I've got 2, how do I multiply that to get to 4? Well, I just need to times it by another 2, don't I? So I need to put 2 there. This is your answer. Now, factorising is the opposite process of expanding brackets. So you can always go and double check, okay, is my answer correct? What I'll do there is just re-expand the brackets. What I mean by that is just multiply it out again. So let's say 2 times x is 2x. Okay, yeah, that's what we had here. And then 2 times 2 is plus 4. Yep, that's what we had there. So I can double check that I factorised it correctly. In this case, I have. So your answer is 2, and then in brackets, x plus 2. So factorising is literally just looking at the terms you have, finding the highest common factor between all of them, and pulling that out on the outside. Then just figuring out, okay, what do I then need to multiply that by to get back to my original in the question? Okay, this next one we now have a combination of letters and numbers that we can use as a common factor. So factorise 15x cubed minus 50x. Okay, so I know it's going to be single brackets. First of all, I'm going to look at the numbers. What's my highest common factor between 15 and 50? Well, I think that's pretty obvious. It's obviously a multiple of 5, so 5 is our highest common factor in terms of numbers. However, in this case, we also can then look at the letters. What's the highest common factor between x cubed and x? Well, they're both divisible by x, aren't they? So I can actually pull out an x as well. So my highest common factor to put on the outside is 5x. And then it's the same from here. How do I get from 5x back to 15x cubed? Well, the numbers first, I have to times 5 by 3 to get 15. And then this is x technically to the power of 1, isn't it? How do I get from x to the power of 1 to x to the power of 3, or x cubed? I need to multiply it by another x squared. Then I look at my next term. How do I get from 5x to minus 50x? So the first thing I'm thinking of is, okay, it's going to have to be a negative, isn't it? Because if 5x is positive and 50x is the negative here, I need to multiply by a negative. Then how do I get from 5 to 50? Well, obviously I have to times that by 10, and then x to x, well, that's just the same thing, isn't it? So actually, I don't need to put anything after that. So let's just move this bracket a bit closer. We don't need that much space. Okay, so that is your final answer. Okay, this one's a little bit tricky because we've got a few things to take into consideration, actually. So, our highest common factor between those two terms. Let's first look at the numbers. 4 and 52. Well, actually, 4 is the highest common factor because 4 obviously goes into itself once, but it also goes into 52. So I'm going to pull out 4. Then I'm going to look at the letters. Now, this one's x to the power of 5 and this one's x to the power of 2. So the highest common factor is going to be your lowest power. So x to the power of 2. Now, there is actually one more thing we can pull out. As you can see, they are both negatives. So I am actually also going to pull out the negative. So my highest common factor is minus 4x squared. And then our process begins again. How do I get from minus 4x squared to minus 4x to the power of 5? Well, we've already got minus 4, so we're missing x cubed. And then the next bit, now, it's already negative on the outside, right? So that's why I'm going to make them positive on the inside. Because when we multiply negative by positive, the answer is still negative. And that's what we want. So I'm going to put plus here. How do I get from minus 4x squared to minus 52x squared? Okay, well, 4 goes into 52 13 times. And the x squared is the same, isn't it? So we don't need any x's. So that will be just plus 13. So we've got minus 4x squared on the outside, and then x cubed plus 13 on the inside. Okay, so factorise minus 3 x to the power of 4y plus 51 x cubed y to the power of 5. Again, we've got single brackets, and my highest common factor, okay, 1's plus 1's minus, so I'm not going to pull out the negative, I'm just going to have a positive on the outside. Looking at the numbers 3 and 51, what's our highest common factor? Well, again, 3 actually just goes into 51 and obviously goes into itself. So I'm going to put 3 on the outside. And looking at the letters, now we need to look at them separately because obviously x is different to y, right? So looking at the x's, we've got x to the power of 4 and then x cubed. So the highest common factor is x cubed. You're going to take the smaller power. And let me just move this bracket along a little bit. And then we're going to look at the y's. So here we've got y, which is obviously technically y to the power of 1. And in the second term, we've got y to the power of 5. So in common, they both have y to the power of 1 in common, don't they? Obviously, I'm just going to write that as y, though. So our common factor, well, our highest common factor on the outside is 3x cubed y. So now on the inside, how do I get from 3x cubed y back to negative 3x to the power of 4y? Okay, well, first of all, you can see that we need a negative because the 3 on the outside is positive. They're both already 3, so we don't need to change the number. However, when you look at the x's, we're missing one x, aren't we? Or x to the power of 1. So I'm going to put x here. And again, the y's are already the same. So the only thing missing was the minus x. Then we say, how do we get back to 51x cubed y to the power of 5? Well, those are both positive, so I'm going to put a plus. Then we need to go, how do we go from 3 to 51? Well, we need to times that by 17. If I look at the x's, they're already the same, aren't they? They're both x cubed, so that's fine. We don't need any more x's. But the y's, again, this is technically y to the power of 1. So I'm missing y to the power of 4. So as you will have seen in the first video on factorising into single brackets, the concept of factorising is that we're basically putting the brackets back in, aren't we? It's the opposite process of expanding brackets. So with factorising quadratics with the trial and error method, we're going to be focusing on the fact that we need to find two numbers that multiply to make whatever this last number here is, and then also they add together to make the middle number. Okay, so this is a straightforward example because everything is positive. You can see it's plus 5x plus 6. So we're not going to worry about the positives, negatives and all that just yet. We're just going to deal with the numbers. So just remember, it has to multiply to make this last number here and add up to make the middle number. Okay, so thinking of two numbers, effectively what we're looking for are the factors of 6, and then we're going to see which ones add up to make 5. So factors are numbers that divide into, for example, numbers that divide into 6. Now, luckily 6 doesn't have too many options, but if you have a question where there's a lot of options, I always suggest starting in order. So what I mean by that is, well, I know it's going to be 1 times 6. Then I'm going to go, okay, does 2 go into 6? Yes, times by 3. And I go, okay, does 3 go into 6? Yes, but we've already written it down. So once I've kind of gone through all the numbers until I've kind of hit myself in the midpoint, I know that I'll have all of the factors. Like I said, for 6, pretty straightforward, but if you have a number that has a lot of options that might be almost larger than the times tables, just go 1, does 2 go in, does 3 go in, does 4 go in, until the point where you meet yourself in the middle, like this. The next number was 3, we already wrote down 3. So out of these ones, which ones add up to 5? Well, pretty obvious. I mean, clearly 2 and 3. So when we're factorising quadratics, we're going to have 2 brackets. If you remember expanding double brackets, you always end up with a quadratic, don't you? So we're going to get 2 brackets. We know that x times x will make x squared, so you can pretty much just put the x's in straight away. In this case, everything is positive, so we don't need to worry. We can just put plus and plus. And then 2 and 3, it doesn't really matter which way around you put them, because either way, they're just x plus something else. The brackets are the same other than that. As we said before, factorising quadratics is the opposite process of expanding, okay? So you can always go back and double check, have I got this right? Does this make sense? Let's say if I were to expand this just to show you, I would do x times x, which is x squared. I would do x times 3, which is plus 3x. 2 times x is plus 2x. And finally, 2 times 3 is 6. Then to simplify, I would just add together those in the middle, wouldn't I? So 3 plus 2 is 5. So you can see that's exactly the same thing. That's why you can see that we need to have 2 numbers that multiply to make this final number. Because this line of the expansion is where we get that final number by itself, isn't it? Just the 2 numbers multiplied together. So you can always go and double check your answer if you're not sure. Just expand it out again and see if it works. Okay, this is where it starts to get a little bit more complex because, as you can see, it's not all just positives anymore. So I'm going to start out by drawing my double brackets because I can see it's a full quadratic. It's just x squared, so I know I can put x and x. And when you have a situation where it's not just all pluses, I'm going to actually deal with what type of symbols I'm going to need first. So if we write them up here, these are the options of the symbols. Okay, it's either going to be both plus in the brackets, both minus in the brackets, or a plus and a minus, isn't it? That's basically our options. As we said, if we have to multiply to make this last number, but the last number includes that plus, isn't it? It's positive 56. And we have to add to make the middle number, which is a negative. So think about it in terms of just positives and negatives. Okay, I'm multiplying 2 numbers, the answer is positive. But when I add them together, it's negative. So in this case, we're going to need both negatives. 2 negatives, when you multiply them, cancel out to make a positive. But if you add them together, it's still negative, isn't it? So that's how I figure it out. Figure out your symbols first because it can then affect what numbers you choose, okay, if it's not all positive. So I put both negatives in, and then I can look at factors of 56. Okay, we know they're both going to be negative. So this is one where there might be quite a few options. Obviously, 1 and 56, I mean, you can see it's probably unlikely that that's going to be the case, but we'll write it down anyway. 2 and 28, and then we go, does 3 go into 56? No, it doesn't. And then you go, does 4 go into 56? Yes. 4 times 14. 5 obviously doesn't go in. 6 we know doesn't go in. 7, yep, 7 times 8. Then my next option would be 8, but obviously as you can see I've already written that down. So that's how I know I've written all of the possible factors. I've not missed any out. So these are my options, and then I have to figure out, okay, I know that both of them will be negative. Which ones would add together to make 15? Well, that would be minus 7 and minus 8, wouldn't it? So that's how I go through and check. Again, because they're both x minus, it doesn't really matter which way around you put the 7 and the 8, okay? They're both just minus. So a common mistake that people make is they look at the 2 symbols here and think, well, there's 1 minus 1 plus, so therefore, in my brackets, it should be 1 minus 1 plus. It has nothing to do with that. It's literally just focusing on, okay, I multiply to make a positive, but I add to make a negative. You know, what combination of symbols would make that work? Okay, the next one. So we're going through the same process, but you can see the symbols are listed differently. So I'm going to start off by just drawing my brackets. Again, it's just 1x squared, so I put x here and x here. Now we're going to see what symbols we need. So out of our 3 choices, 2 pluses, 2 minuses, and a plus and a minus. Now we can see we're going to multiply to get a negative. I don't really even need to look at the next number, do I? Because the only way to multiply to get a negative is if we've got 1 positive and 1 negative, isn't it? If we have 2 positives, well, there's just no negative involved anyway. If we have 2 negatives and we multiply them, they would cancel out and make a positive. So we have to have a plus and a minus. This is where it makes the difference as to when we figure out the middle number, okay? Because if you've got 1 plus 1 minus, when you add them together, technically this number here is the difference between them, isn't it? So that's why we need to know which symbols we need before we figure out the factors. So I'm going to put plus and minus there. And then factors of 21, luckily there aren't as many, 1 and 21. 2 obviously doesn't go in. 3 times 7, and that's pretty much it, isn't it? 4 doesn't go in, 5 doesn't go in, 6 doesn't go in, and then you're back to 7. So out of these 2 options, but remember that 1 is a plus, 1 is a minus, so you might want to list out even just writing it as plus this, minus that, and work it out. But effectively, this is the difference, isn't it? So 3 and 7 would give us a difference of 4. But we also have to figure out which one's the plus and which one's the minus. This is where it now is important. We can't just chuck in 3 and 7 as we want. We need to actually specifically put the right number with the right positive and negative symbol. So overall, we want it to add up to positive 4. So if we had minus 3 plus 7, that would give us positive 4, wouldn't it? But let's say if we had 3 plus minus 7, that would be minus 4. Either way, the difference is 4, so we know it's 3 and 7, but we have to make sure we get them the right way round. So in this case, we need the 3 to be the negative and the 7 to be the positive. Effectively, the bigger number is the positive, isn't it? Because our difference is positive overall. So our answer, we've got x plus 7 times x minus 3. So let's just jump into our first example. Now, we already know how to use the trial and error method to factorise quadratics in general, and we know that we basically got 3 steps. So it really depends on the harder quadratics. What we're referring to is the fact that there is a number in front of the x squared. Because not only do we have to worry about the combinations for the third term and the middle term, but we also have to worry about this number too. We're starting off with some easier examples where this number in front is a prime number. Now, a prime number is a number where the only factors are 1 and itself. So for example, I can only do 1 times 2 to make 2. Okay, obviously whole numbers wise. There are no other factors. So we're starting off that way because it's a little bit easier. In that sense, our first step is always to draw the double brackets and to put the x's in. But obviously this time we can't just put x and x because it's not 1x squared, is it? It's 2x squared. So this is where the fact that it's a prime number comes in and is really handy, because I know that to split up the 2x squared, the only way is that one of them has to be a 2x and the other one has to be x, doesn't it? Well, and that's effectively 1x. There's no other way to split that up, is there? There's no other way to split up a 2. It can only be 1 times 2. So if you've got a prime number in front of your x squared, using the trial and error method, even for a harder quadratic, is still okay. You already know 2x and x, that's my only option. Now you remember that our second step is always to work out the symbols, okay? Always work out the symbols before you start dealing with what factors we need, because it will affect how they add up in the middle. So we've still got the same options for symbols. Either both brackets are going to be plus, both are going to be minus, or we're going to have one of each. And that depends on these second 2 values. So here we're saying we're timesing to make a positive. Okay, well, that narrows down this option, doesn't it? We can't have a positive and a negative because those would multiply to make a negative, so we can't have that one. We could have 2 negatives because that would multiply to make a positive, and obviously 2 positives would multiply to make a positive. So, because we don't know between these 2, we're going to have to then look at the middle number. The middle number is what we add together to make, isn't it? If you have 2 negatives, yes, they multiply to make a positive. However, when I add them together, they're still negative, aren't they? So I can't have that option either. I'm going to have to use both positives. There are no other negatives involved, are there? So that's quite nice, because also, being that they're the same symbol, I don't have to worry which bracket is which. I can just put them both in straight away. Then our third step is to find the factors of this final number, so factors of 3, that would add together to make 7. Now again, I've chosen a fairly easy one because 3 is also a prime number. The only factors is 1 times 3. So I'm using this to kind of demonstrate because at least we don't have to choose between different options. Okay, we know it's going to have to be 1 and 3. However, in this case now, as you can see, one of the brackets is 2x, one of them is x. So we can't just throw the 1 and the 3 in randomly. We have to figure out which bracket is which. You're probably also thinking, well, 1 and 3 don't add together to make 7. No, they don't. But that's because one of these two numbers will be multiplied by 2. As we know, factorising is the opposite process of expanding, isn't it? So if you imagine that we were expanding this, we would have 2x times x, obviously that gives us our 2x squared. We would then do 2x times by whatever this number is. So that number is going to be doubled. We would then do this number times x, so that's just itself. And finally, those two numbers, obviously the factors, have to make 3. Okay, so we've got these two values here which have to add together to make 7x. And one of these two numbers has to be times by 2. Now this one's pretty straightforward. Obviously, we're going to need to times the 3 by 2, aren't we? To make 6, and that's just 1. So if I were to expand that, obviously I'd have 2x times 3, which is 6x. Then I'd have 1 times x, which is just x. And you can see that's how we make the 7x. Okay, so that's your answer. You've got 2x plus 1 times x plus 3. Okay, so it's really important that we not only figure out the right numbers, but which way round do they go in the brackets in order to make that middle term. Okay, as you can see, the possible combinations start to get a bit trickier again because our last number isn't a prime number anymore and we have some negatives involved. So my step 1, I can still write it with the x's because 3 is a prime number, so I need 3x in one bracket and x in the other. Then my symbols, what do we have? So we need to multiply to make a negative. Okay, well that immediately eliminates these two, doesn't it? We have to choose a plus and a minus. Now this is where it gets a bit tricky because I can't immediately go and write down plus and a minus because given that they're different, I don't know which way around it's meant to go, right? Because one's 3x, one's x. So I have to kind of hold fire on this example. Okay, so I know it's going to be a plus and a minus. I'm just going to write it here so I don't forget. But I need to figure out my numbers before I can actually put it into the correct brackets. I don't know if it's going to be plus here or a minus, or a plus or a minus. I don't know which way around it's going to be yet. Okay, so that's why it's a little bit trickier. And our step 3 is still factors of 16, but remember, when you're adding them together to make 2, one is a plus, one's a minus, okay, so just bear that in mind. But as we said in our previous video, when you know that your symbols are going to be 1 plus, 1 minus, this middle number is effectively the difference between the two factors. So first of all, let me just write out the factors of 16. 1 and 16, and 2 and 8, and then 3 doesn't go in, 4 times 4, and we've met ourselves in the middle. So those are all of our factors. Now, bearing in mind that one of those factors will be times by 3, then the difference between them is 2. Okay, that's quite a lot to take in. But yeah, you can always test it out. The fact that the difference is only 2 means that the numbers, even after one of them has been multiplied by 3, must be very close together. So if you think about it, like let's say if I multiplied 3 by 1, 3 and 16 are still very far apart, okay? So it's not going to be that. So I can, even without trying it out, I can kind of already eliminate that. And 4 times 4, well, they're already basically the same number. If I times one of them by 3, well, that's 12. 12 and 4 are not close together, so I can cross that out as well. Okay, so I'm not even really trying them out. I'm just in my head going through, right, which ones are going to be closest together. So we're left with 2 and 8. If I times 2 by 3, so 3 times 2 plus 8, that gives me 6 and 8. Now, obviously, one of them has to be plus and one of them has to be minus, so just bear that in mind. 6 and 8, yeah, that difference would be 2, wouldn't it? Let's say, though, if I had it the other way around, and it was 3 times 8, I've put a minus here because obviously we know one's plus, one's minus. You can see that that would be 24 and 2. Well, that would be way too far apart, wouldn't it? So not only do I have to figure out which number, which factors work, which number has to be multiplied by 3, but then I also have to figure out which one is plus and which one's minus. So you can kind of see where we're starting to get a lot more tricky. Now, in this case, the 2 is positive, so we need the bigger number to be the positive. Now, 3 times 2 is 6, so 8 is still bigger, isn't it? So the 8 needs to be the bigger number or the positive. Now, because we said we're timesing the 2 by 3, the 2 has to go here, doesn't it? Because when we expand, that's the one that's going to be multiplied by 3. And we've just said that one has to be minus. And then we have plus 8. So it's just a lot of trial and error. Like if you need to write down as many possible combinations as possible, that's absolutely fine. Just write down as much as you can if you need to. Some of them will be more obvious than others. Okay, but this one I helped myself with that little trick of knowing, okay, if I have a plus and a minus in my brackets, I can kind of just eliminate anything that is a lot further apart than 2. But you do have to consider the fact that it's not just the difference between 2 and 8, it's the difference between one of those times by 3 and then the other one. Okay, so it's quite tricky. This is where you can see it's getting a lot more complex, and that's why they class it as harder quadratics. Okay, again, this is now a much harder example. So I've got 6x squared. So if I had to draw my brackets, I don't know if it's going to be 6x and x or 3x and then 2x. Okay, luckily it's still only 2 options, but I don't know which of those 2 it is going to be. Then I want my symbols. So we've got either both pluses, both minuses, or one of each. So that depends on our last number here. So we're multiplying to make a positive, so we've already eliminated this option. Okay, luckily it's not too annoying having one of each. Then we need to check the middle number. Okay, but when we add them, it makes a negative. So if we've multiplied them to make a positive, but when we add them, it's a negative, we're going to need some negatives in there somewhere. Okay, luckily it's both negative, so I can just write them in immediately. That won't make any difference. And finally, we're going to look at factors of 28. So we have 1 and 28, 2 and 14. 3 doesn't go into 28. 4 and 7. 5 doesn't go into 28. 6 doesn't go into 28, and 7 does, but we've already written down 7. So that is all of the possibilities. So you can see here we've got quite a few possibilities. We don't know if it's 1 and 28, 2 and 14, or 4 and 7, but we also don't know if it's 6 and x, or 3 and 2. Right? So you just kind of have to just either go through in the right order or just test them out. Now, intuitively, you're going to think, oh, 1 and 28, that makes minus 29. However, we know that we're going to have to multiply them by something. So I'm immediately thinking it's not going to be that one, okay? Let's try out 2 and 14. So they add together to make 29, so they can't be that big in the first place. So let's say, well, I know if I times 6 by 2, that's going to make 12 plus 14. 12 plus 14 is 26, so it's pretty close, but it's not quite right. And also, if I do it even the other way around, because 2 and 14 are both even numbers, no matter what I multiply them by, I'm not going to get an odd number, am I? Okay, so I can also eliminate that option. The last one, we've got 4 and 7. Okay, one of them is an odd number, so that's fine. We just need to figure out which of these 2 brackets would that go into. So let's just try it out. 6 times 4, that'd be 24, plus 7. 24 plus 7 would give me 31. Okay, slightly too big. If that's too big, then me then multiplying the 7, which is a bigger number, by 6 is going to be way too big, isn't it? So I'm going to assume it's not the other way around. So again, we know that this is an odd number. If I multiply the 4 by 3 and the 2 by 7, they're all going to come out as even numbers, aren't they? So I actually know I need to combine the 2 odd numbers together. So immediately I know I can do 2 times 4. That'll come out even either way. But then 3 times 7 is odd, isn't it? 2 times 4 is 8, plus 3 times 7 is 21. So 8 plus 21 is 29. Okay, so there's kind of a process of elimination that can help you speed it up. So I know that I need to multiply 4 by 2, so 4 has to come over here, actually. And the 7 has to go here because, you know, when you expand, you're obviously multiplying with a different bracket. So we can't use the 6x and the x, we have to use 3x and 2x. Okay, our final question here, even trickier because the 12x squared, well, we know 12 actually has quite a few factors, doesn't it? So it could be 12x, it could be with the x, we then could have 6x and 2x, but we could also then have 3x and 4x. Okay, so that's the issue, we've got 3 possible brackets. But let's go on from there. We then need to worry about our symbols. So what combination of symbols are we going to need? We're multiplying to make a negative. Okay, that's going to be an issue, isn't it? Because multiplying to make a negative means we need one of each. So not only do we have 3 options of brackets, but also we can't even put the plus and the minus in there just yet, because it will obviously be different depending on which numbers are which. So we know it's a plus and a minus, we just don't know which way around. And I'm just going to do it over here. So factors of 9. Luckily, we've only got 2 options though. We've got 1 and 9, and 3 and 3. So luckily, we've only got 2 options. And also, having one where the 2 numbers are the same thing is a little bit easier as well. Now we're just going to test it out. We need to add them together to make 52. But remember when we said if you have a plus and a minus, The middle term is the difference between the two factors. And I don't just mean the factors like this, but the factors once you've multiplied them by whatever x's you have. So 52 is quite far apart. Okay, so that's kind of giving me, I mean, there's still a lot of combinations. You could times it by 12, or you could use the 1 and the 9 being a much bigger number. But 52 is quite a large number, isn't it? So I'm assuming it's not going to be like 3 times 3 and 3 and 4, right? Because I don't think that would be big enough. So I'm going to try the 12 and the x. The 52 is even, okay, so it doesn't narrow it down too much. But it does tell me that I can't do x times 9 and 12 because that wouldn't make an even number. Now 12 times 9 is obviously a number bigger than 100, right? 108, so that's just way too big. So we can't use that one, okay? 12 and then the 3s, let's try that. So 12 times 3, and then obviously minus here. Minus 3, well that's 36. Minus 3 is 33, okay? So it's still not a big enough difference. Okay, so we're not going to be using the 12 and the x. Let's try the 6 and the 2. So I know that 6 times 9 is 54. Now that's quite similar to 52, so let's try that one. 6 times 9 is 54, and then we'll obviously have to do 1 minus. And then 2 times 1 is 2. 54 minus 2 is 52. So you can see I was actually quite lucky there. I actually got it on like the 3rd try, but just because I was really looking at the numbers and trying to figure out the clues. Obviously, you can just go through and test them all out, but you might be unlucky as to, not finding the right answer in the end until literally your last trial. Okay, so I know that the 9 has to be multiplied by the 6, and the 9 has to go in this bracket, and the 1 has to go in this bracket. Okay, it's not going to be the 3 and the 3. However, I then need to figure out which one's plus, which one's minus, because overall I need minus 52. As you can see with my experiment here, I put a minus in front of the 1. Now that made positive 52. So I need to put the minus with the bigger number, not just the fact that 9 is bigger, but the fact that when I times it by 6 is obviously bigger than 2, isn't it? 2 times 1. So minus 9 here and plus 1 here. So it's going to be 6x plus 1 and 2x minus 9. Not that one either. Okay, so it just takes a bit of time to get used to it. Make sure you write down all the trials, because otherwise you can get quite confused in your head and end up maybe adding them up wrong. And you feel like you've tested out all the options and none of them work. Obviously, if they're asking you to factorise, then it is possible. So just make sure you write it down and just really try not to get it all mixed up, because it is quite difficult. So what do we mean by harder quadratics? Well, basically, it's the quadratics where we've got a number in front of the x squared, and I would say, more specifically, a number that's not a prime number. So prime numbers are those numbers where the only factors are 1 and itself. For example, 2, 3, 5, 7, 11, so on. 6 is obviously, you can do 1 times 6, you can also do 2 times 3. Okay, so it's not a prime number. The issue with that makes it harder is that then we've got so many possible combinations that we have to try and figure out, on top of already trying to figure out the combinations of 12, 17, and so on. So that's what we mean by harder quadratics. Therefore, sometimes trial and error method can be really, really difficult if you've got so many possible combinations to figure out. So the splitting the middle term method is here to try and reduce the trial and error part. So what we're going to do is, quadratics are normally written in this format: ax squared plus bx plus c. A, b, and c just represent the coefficients. So for example, 6, 17, 12, that's what a, b, and c are. What we're going to do is, we're going to come over to this corner, we're going to do a times c. So 6 times 12. Now, obviously, if that c is a negative, include the negative, right? But in this case, they're both positive. So 6 times 12 gives me 72. So what I'm looking for, and this is where it's very similar to trial and error, is I'm looking for two numbers that multiply to make 72, but they also add up to make this middle number, the b, minus 17. So before we figure out the factors of 72, as always, we need to know what symbols do we need. So we're multiplying to make a positive, but when we add them together, it's negative. So we're going to need two negatives. Then I'm thinking, right, factors of 72. Which ones would add together to make minus 17? Now, when they add together to make minus 17, as in the total is minus 17, in themselves are probably quite small, so you can probably already see which ones those are going to be. Like, obviously, it's not going to be 1 and 72, is it? Because if you add those, nowhere near 17. So it kind of helps me narrow it down. I'm just immediately assuming it's going to be 8 times 9. Because that makes 72, but also 8 plus 9 is 17, isn't it? So I've got minus 8 times minus 9 is positive 72. Minus 8 plus minus 9 is minus 17. Okay, now that bit is basically the same. Obviously, the difference is we've done a times c first. So we're not figuring out factors of 12, we're figuring out factors of 72. Now I'm going to come back to the middle. This is what we are referring to when we say splitting the middle term. The middle term is the b, isn't it? Literally this term in the middle. That's what we're going to split. So what you're going to do once you've done this, I'm going to call that, right, that's step 1. Step 2 is you're going to rewrite your quadratic, but split the middle term into these two values. So what I mean by that is I'm going to write the 6x squared still, but instead of writing minus 17x, I'm going to write, now it doesn't matter which order you put them in either, you just put them whichever order you like, but use obviously the correct symbols, minus 8x minus 9x. Now overall that still adds up to minus 17x, doesn't it? And then I'm going to copy the plus 12. Okay, so this is exactly the same quadratic as the top one, I've just split the middle term. Okay, I've literally split it. What we're going to do now is we're going to factorise, but it's a lot easier because we're going to factorise into single brackets. So imagine there's a little line here. If you just look at the first two terms, how can we factorise that into single brackets? What is the highest common factor between 6x squared and 8x? Well, in terms of numbers, that's going to be 2. And in terms of the letters, we've got an x, haven't we? Then in the brackets, to get from 2x back to 6x squared, I have to times it by 3x. And then to get from 2x to minus 8x, I need to times by minus 4. Okay, and then we're going to factorise the second bit. So the highest common factor between minus 9x and plus 12 is 3. Now this is where you've got to try and figure out the symbols. You know, am I going to pull out the negative out here? I'm going to put it inside the bracket. I'm going to deal with that in a minute. I'm just going to write down the numbers and the letters. We'll deal with the symbols in a minute. So to get from 3 to 9x, I need 3x, and to get from 3 to 12, I need 4. Now, this is where you'll know whether you're right or wrong, because these two brackets have to be identical, okay? So first of all, if they're not identical, you know you've done something wrong. But second of all, the fact that I know they need to be identical tells me I have to have this as a negative. Therefore, I know that I need to put a negative on the outside. Okay, so when I times this, I get minus 3 times 3x, gives me the minus 9x. But then I do minus 3 times minus 4 gives me that positive 12. Okay, so they have to be identical brackets. Now, your final step is your answer. We're going to create, obviously, the actual two final brackets. One of those brackets is obviously going to be one of these two. So they're identical, so you only need it once. So 3x minus 4. Okay, so these need to be identical, and that's going to be one of your brackets. And then the other bracket's going to be whatever else is on the outside. So you can see these two pieces are separate. So we've got 2x minus 3. Okay? This is your final answer here. So you can see, if you've already watched the video that we did on using the trial and error method, we would have had to figure out if it was going to be 6x and x in the brackets or 3x and 2x. You can see in this method, it's figured it out for us. We didn't even have to worry about this first term. Okay, we just had to do a bit of trial and error on the side, but it didn't really involve the first term that much, did it? And obviously factorising into single brackets is pretty straightforward. And I actually quite like this method as well, because you can guarantee that you've got the answer right, because if you've ended up with the two brackets being identical, you're pretty sure that you've got it right. Okay, so you've got some kind of like positive feedback there. So we are still doing a bit of trial and error in this corner, but it's not as much as trying to figure out the 6x squared and the 12 and this and that. But as you can see, we had to have two negatives anyway, so we've got that. 3x and 2x would multiply to make 6x squared, and 4 and 3 makes 12, so that's worked out anyway. Even though we used 72, it still worked itself out. So that is the whole of the splitting middle term method. If you haven't seen it before, it might take a while to kind of really remember it. You might decide, you know what, it's just easier if I remember one method, trial and error for all of my quadratics. Absolutely fine. However, if you're really struggling with the trial and error method for these harder quadratics, you might be happy to have two methods. Obviously, this method is kind of pointless if it doesn't have a number in front of the x squared. Because if you then do a times c, you're doing 1 times the c. So it's not making any difference, is it? So this is only really a method for when you've got a number in front of the x squared. You just decide, do I want to memorize two methods? Is that going to make my life easier? Or is it just easier to have one method and not complicate myself? Okay, this is our last question, so try this one out yourself, pause the video, and then come back to see if you are happy with the method. So back to the same again, a and c. A times c is our step 1. So 20 times minus 15. Okay, so we're going to get minus 300. Now, this is the only thing that could be slightly difficult, but hopefully you'd have a calculator test if this came up, is because obviously, okay, 300 is an alright number, but it is quite a big number, right? So finding factors, sometimes if you end up multiplying the a and the c together, you might get quite a big number, and that can sometimes be a little bit harder. So it's really up to you if you think this is easier or if you don't. Okay, so we need two numbers that multiply to make minus 300, but they add up to make 13. So what symbols do we need? Well, if we're multiplying to make a negative, we need a positive and a negative, don't we? So I'm just going to write the negative here, because I don't really need to write the positive. But if you remember, when we have a positive and a negative, this middle number is the difference between the two factors of 300, isn't it? So 13, in the context of 300, I guess those factors are fairly close together. You know, it's not 1 and 300. It's not 2 and 150, right? They're fairly close together. So that helps us narrow it down a little bit. So factors of 300, obviously, like I said, I'm not going to just write down 1 and 300 and so on. I'm looking for things that are a bit close together. The other thing to consider is if there's a difference of an odd number, we can assume, obviously, that 1's an even number, 1's an odd number. So that gives you a bit of a hint as well. Obviously, we use 20 and 15 anyway to make 300, but the difference between those two is 5. It's not big enough difference. So we're looking for numbers that are like one number that's smaller than 15 and one that's bigger than 20, but not too far beyond that. So if we think about it, obviously we have 10 and 30. The difference would be 20. That's then too far. So we've got, what did I say, 10 and 30. Well, the difference is 20, too big. And then we already used 15 and 20, didn't we? Where the difference was 5. So you can see by process of elimination, I can see I need something where the factors are between these two numbers. Now, thinking of 300, I'm thinking kind of towards 12. And what do I need to times 12 by? Well, it's actually 25, isn't it? Now, the difference between those is 13. You can see one's even, one's odd. Those are the ones that are going to work. Okay, so I can kind of, even though 300 is a big number, it's got a lot of factors, just by really just thinking about it logically, I can kind of limit myself. I can limit the time by not having to test out every single number. Okay, I can kind of give myself a guide as to what I'm aiming for. Now we need to know which one is positive, which one's negative. So you can see when we add them together, we get positive 13. So the bigger number has to be the positive. So we need 25 and minus 12. Okay, so that would multiply to make minus 300, and it would add to make 13. So step 2, we're then just going to rewrite the quadratic, but split that middle terms, the middle 13, into these two numbers. Again, doesn't matter which way around you write them. So I'm just going to put plus 25x minus 12x, and obviously then copy the rest, minus 15. Okay, we're not using the 300 anymore, right? Then we're going to factorize both halves into single brackets. So the highest common factor between 20x squared and 25x is going to be 5x. So inside I then need to put 4x and then plus 5. So now I know my second bracket's also going to have to be 4x plus 5. Okay, highest common factor for the second two, 12x and 15, is 3. And then I know that can be 4x and 5, but as I said, we need to have identical brackets. So it's going to have to be a plus. So again, we're kind of in this situation again where we need to pull out the negative. You don't always have to, it just depends. These kind of examples we've just been having seem to be all similar, but you don't always have to pull out the negative. But in these cases, we have had to. Okay, and our final step is to just write out our final answer in two brackets. So, as I said, the first bracket's going to be 4x plus 5. I mean, it doesn't technically matter which way around you write them. It's just whichever comes first, but I just had to put those first. It's a bit more obvious. And the second bracket is then whatever is on the outside of the bracket. So we've got 5x minus 3. And you can see we said before we need a plus and a minus, which we've got. To make 15, they've gone with 5 and 3. That's what we've ended up with. And to make 20, it's been split into 4x and 5x. We didn't need to worry about how the 20x squared was going to be split up. It just figured it out for us, didn't it? So we didn't know, is it 20x or x? Is it 10x and 2x? Is it 4x and 5x? We didn't need to worry. It literally just figures it out for you. So first of all, what is the difference of two squares? Well, as you can see here, we've got an expression that is x squared minus 16. Okay, well, first of all, x squared is a square number, isn't it? It is literally x times x, which is a square number. And 16 is also a square number, isn't it? It's 4 times 4. So those are the two squares, right? We've got a square here and a square here. And then a difference is always subtract, isn't it? If you want to work out the difference between two numbers or whatever it is, you're going to subtract them. So this is the format of the difference of two squares. And I tend to see a lot of questions like this, literally like 2 marks in an exam, but it's just so easy to pick up these marks because it's not even anything to do with trial and error method or splitting middle term or anything really. It's not even really a method. It's just kind of knowing what to do and you can just write down the answer immediately. So this is still a quadratic. However, you can see that we are missing the middle bit, aren't we? Normally our quadratics are in the form of ax squared plus bx plus c, and that's what we've been factorising, isn't it? They need to multiply to make c and add up to make b. Well, this is kind of true as well. It's just this one is x squared plus 0x minus 16. Okay, so it does technically have the middle part, but obviously we don't write it because it's just 0. But what we're saying is that the factors have to add up to make 0, or effectively cancel each other out. So, and I'm going to go through it in the trial and error method, however, when you actually work out what to do, you don't need to do it this way. You'll just remember what we need to do. So we're going to be multiplying to make minus 16, but they need to add up to make 0. Now, if you saw a trial and error method, you know that if it's just x squared, either way it's going to be x and x in each bracket, isn't it? Then we like to look at the symbols. We're multiplying to make a negative, which means we need a plus and a minus. And then you're going to say, right, factors of 16 that add up to make 0, obviously plus and a minus. Now this is where the square comes in, because if you want to add two things together and it to cancel out or to make 0, they have to be the same thing, don't they? Obviously one's plus, one's minus, but they have to be the same number, which is why it needs to be a square number, because we're going to use 4 and 4. So I'm just going to put 4 and 4 here. Now let's say if we were to expand this, you can see we'd get x squared, we'd get minus 4x plus 4x, and then minus 16. Okay, so you do have this middle bit. However, now if we then simplify it, you can see that the middle bit is going to cancel out. Minus 4x plus 4x is just 0, isn't it? It's just not there. And then minus 16. Okay, so I've obviously gone through kind of the background explanation, but my point is if you can recognize this type of quadratic where you've got ax squared minus, it has to be minus, right? Because we're obviously multiplying a plus and a minus. Ax squared minus c, you can still factorize it into 2 brackets. You just have to recognize that they're both square numbers. You need to do 2 brackets, one a plus, one a minus, and just the square root of each of these. So obviously the square root of x squared is x, and the square root of 16 is 4. You're not even having to really think about trial and error or anything. Obviously, I've just shown you how it works. But my point is if I saw this question, immediately I'm thinking, right, x plus 4, x minus 4. I'm not even having to actually work it out, if that makes sense. So that's what the difference of two squares is. And I know a lot of students get stuck on this question because they see it and they go, well, I can't factorize it as a quadratic because it doesn't have the 3 parts. But I can't factorize it into single brackets because there's not anything in common. And then they're kind of stuck. So don't get caught up in that. It is still possible to factorize it into 2 brackets. Okay? Identical brackets, but one's plus, one's minus. Now, I want to show you a few other questions which are a little bit trickier. It might kind of throw you a little bit, right? Because you're looking at this going, okay, yeah, we've still got that same situation of like ax squared minus c, but is it the same because I've not seen it with a number in front of the x squared before? Yeah, it's the same. Obviously, the number in front of the x squared also has to be a square number though, right? So in this case, I'm still going to do the same thing, square root the whole of this, which is obviously 2x, not 4x squared, plus square root of 9 is 3, and then 2x minus 3. It still works. Because I don't know if a lot of people know, but 2 square numbers, obviously 4 is a square number, and x squared is a square number. When you then multiply those two together, the answer is also a square number. An example of that, if I just use those numbers actually, if I did 4 times 9 just in separately to this question, it's 36. 4 is a square number, 9 is a square number. 36 is also a square number, isn't it? So you can see what I mean. If I do 25 times 4, both are square numbers, the answer is 100. That's also a square number. Okay, that's separate to difference of 2 squares. My point is if you've got 4 as a square number and x squared as a square number together, that as a whole thing is also a square number. Okay. Okay, now I want to highlight a very similar question again, but slightly more difficult. So you're probably looking at this and you're thinking, right, well, yeah, okay, it kind of looks like the same situation, ax squared minus c. So you might be thinking, that seems like difference of two squares. I don't have the middle bit, they're saying to factorize it. However, then you realize you look at the 2 and you go, well, that's not a square number. And you look at the 98 and you go, well, that's also not a square number. So then you're kind of like a bit thrown, okay? This is what I would call where they have kind of difference of two squares but hidden. They've kind of disguised it. The other thing is to really pay attention to the language that they put in the question, because you can see here it doesn't just say factorize, it says factorize fully. Now, 2 reasons for that. 1, because you could probably see, I could just pull out 2, and you might just then leave that as your answer, okay? When it says factorize fully, it normally means there's like 2 steps to factorizing it. Obviously, all of the other difference of two squares questions was basically just 1 step, wasn't it? So I just want you to be aware that they might have difference of two squares, that they might have kind of disguised it by multiplying it by something that's not a square number. So what I mean by that is, in this case, I need to pull out the 2, because that's hiding everything. So first I'm going to pull it out as single brackets. I've got 2 on the outside and then x squared minus, and obviously 98 divided by 2 is 49. Now some people would just factorize it like that and go, oh yeah, I've pulled out the common factor, like that's all I can do. Okay, yeah, 1 mark, but this is a 2 mark question, right? So what we want is then to go, oh, okay, now I can see this is clearly difference of two squares. I just happen to have a 2 on the outside, which is fine. So when it says fully, that was step 1, but then you need to go, oh, okay, yeah, now I can do the same as before, where it's going to be x plus 7 and x minus 7. Okay, so you might look at something and go, well, that seems like difference of two squares because it's this minus this, and there's not the middle number, but the thing is they're not square numbers. And then you might see the fact that says factorize fully. It's literally hinting at you to kind of dig a bit deeper. Just pull out, not necessarily the number that's here, but whatever number you need to then be left with square numbers, okay? So in this case, we did need to pull out the 2. Then you can factorize the difference of two squares into 2 brackets. Okay, so that's everything on factorizing. We've been through factorizing single brackets and then multiple different variations of factorizing quadratics. It's so important that you are really good at factorizing quadratics, because especially in higher tier, it's not just the question of factorize this quadratic, but it comes up in so many different topics. Okay, so thanks for watching this video. Make sure to subscribe, leave any comments down below if you have any questions, and check out the other playlists we have.